Good morning. This is going to be a short class on vertical curves. This class is designed just for a refresher. It's for the people who's already had the 2-hour lecture on how to do these problems. And this is just kind of a refresher because I know even 2 hours we can went kind of fast and furious on this. Okay, remember, the first thing I give you, the given on the vertical curve is, remember, I give you L, which is the length of the curve. In this case, it's 300. I give you the G1, which is negative 3.2%. G1 is from the beginning of the curve to the middle of the curve, which is the point of vertical curve to point of vertical intersection down the tangent. Means that this is negative 3.2%. And remember, this is not a negative number. It's just indicating that that is going down. Okay, G2 is from the PVI to the PVT, which is back point of vertical tangents, back where the road goes back out. Remember, this black part is the tangent. The blue part, we're going to get to later, is actually the curve. Okay. This is 1.8%. The PVI elevation is 30 plus 30. The PVI station number is right here. The PVI elevation is 465.92 feet. That is the elevation of the PVI down here. Okay. I'm also going to talk about the way we divide this curve up. The first half of the curve we call L1, and we call this L2, which is half of 300, of course, which is 150 each side. Okay, the first thing we do is we're going to go to 1. You have to find A. A is G2 minus G1, so A equals 1.8 minus negative 3.2. Negative is a positive, so we're looking at, anyway, it turns out to be 5. Next, we need to find the PVC and the PVT station number. Simply the PVI minus L1, which we're basically just saying, since we have the elevation for the middle of this curve, remember 30 plus 30, you just forget the plus. This is like 3030. So 3030 minus 150 give you 2880. Put the plus in the middle, make it a station number. And then to get this station number is the PVI station number plus L2, which is 30 plus 30 plus 150, which equals 31.80. That's simply what this step is here. We're in the next step. We need to find the PVC elevation. Okay, I have L1 times the G1% slope. Okay, I'll explain that a little bit more. So the answer is added or subtracted from the PVI elevation. Means if it's a dip, it's added. If it's a hill, it's subtracted. That's simply saying we're going to work the curves. We're going to work, and we're going to get, because here we have the percent slope and we have the run, which we need the rise. And we use our wonderful little cheat sheet we have over here. So we have run times percent slope equals rise. That's how far we're going up here from this elevation. So we have 150 feet of run times 3.2% slope. Remember, turn this into a decimal number, 0.032. So 150 times 0.032 equals 4.8. That's feet. So we add it to this number and we get 470.72. Same thing on this side, but remember we have a different percent slope, and I have erased this right here, unfortunately. That was, so it's going to be 0.018 for this side. Oh, there it is right there. So here we did 150 times 0.018 equals 2.7 feet. So 465.92 plus 2.7 equals 468.62. Now that second part I said, it says dip add, H subtract. If this is a dip, meaning the hill is going down. This is the vertical curve. Okay, if this was a hill, this part right here would be going up. So we'd be working the formulas and we'd be subtracting these numbers that we'd come up with and coming down this way, okay? But we're dealing with a slope, so we added them. The next thing we have to do is get the low point distance. And it is to get x equals negative G1 times L divided by A, which is something we got up there earlier. So negative 3.2, so negative is going to equal positive, times 300 is going to be 960, divided by 5, which was the A, is going to equal 900, divided by 5 is going to equal 192 feet. This low point, this is a low point distance, okay? 192 feet is the distance from here to here. We add 192 feet to 28 plus 80, which equals 30 plus 72. Okay, it's on this side of the PVI, so we just put a little mark there. That's going to be our low point in the road, okay, as we come down later. All right, then we've got to get, and that's what the station I did. Number 5 is low point station number. I did the PVC station number, which is down there, plus the low point distance. That's what I just did, 28. We got station number 5. Now, I just kind of call these 1, 2, 3, 4, 5, just kind of the way I do it. And then I call 6 kind of a whole chart. Now, we set the chart up like this. We've got a column for station number, tangent elevation, got a little X in there, we kind of throw that in there, I'll talk about that later. Tangent offset, and curve elevation, and this has nothing to do with anything. I should have erased that. Okay, station numbers. Okay, these we had given. We had 28 plus 80 is PVC. We can put that in. We've got this number, the PVI. We put that in there. We put the low point in there. We put them in numerical order. Then down here we have the PVT. And we're going to put in station numbers. We're going to shoot this at every 100 feet intervals, including what we already have. So 28 plus 80, the next station is 29 plus 00. Then we can get 30 plus 00. Back to the PVI. That one, the next 100 is 31 plus 00, 31 plus 80. Okay. Then we've got to do the tangent elevation. This one's given because the road starts where the tangent and then the actual curve, they start together and then they end together. So this elevation is given. These are different, so I have to run from here to here. I've got to calculate it's 20 feet from here to here. So it changes my formula for my rise. So I do 20 foot of run times this is going to give me a rise of a distance. It's going to give me that it's going to give me the distance if you went straight across and then straight down to that. So you'll say 20 times rise, 20 times percent slope, you'll get a number, and you'll subtract it from here. Then I've got to go to here, 120 feet. 120 times the percent slope is going to give me another number, and I'm going to subtract that number from this, and I'm going to get this elevation. Okay, this one is already given. Then we got to come on the other side, and we go this way because this is a different slope. This is 0.018. So here, this station number goes 80 feet to that one, 108 feet to that one. So 80 times that percent slope is going to give you how far that went down from here. Then we're going to do 108 times this percent slope, and it's going to let you know how far you went there. You're going to get a number, you'll subtract it, and you'll come up with that elevation. Whew, glad I got my running shoes on. All right. That's what these mean. I put them in a separate column because I'm going to need this X later when I'm working on the problem. So this is 20 feet from there. This is 120 feet from there. Okay, and this is 150 from both sides. Don't really need that in there, but I just put it in there anyway. Okay, now this is 80 feet. This is 80 feet from here. This is 108 feet from here. Okay, so that I worked those up. That's the ones I had the little lines, and I mark them on there just so I can see them when I'm working them. Now, we got that. Next thing I'm going to do, we're going to move up to, let me see. That's kind of what step 7 was. PVC minus the distance 9% grade. That's just kind of a written description of kind of what I did. Okay, well, we just explained. All right, the next thing we got to do, we got to go to 8. Okay, we got to get the mid-chord elevation. The mid-chord elevation is the PVC elevation plus the PVT elevation divided by 2. You're simply getting the average of this and this. So you're going to get an average of anything, obviously, you add them up, divide them by 2. So 470.72 plus 468.62 divided by 2 equals this. Now, I have a little note right here. This is not the curve elevation. These are called the tangent elevations. These are called the curve elevations. Okay, that is not the curve elevation for the PVI. Reason I wrote that note for a purpose, because people make mistakes. I get a lot of wrong answers with that. Next, we got to get the tangent offset at the PVI. Now, what the tangent offset is these red lines here. If you can see them, these are tangent. This is the tangent. This is how much the tangent is offset from the curve, or vice versa, however you say it. These are these distances. But that one is only for this one right here. Okay? It's going to be the tangent offset at the PVI, and we also going to call this little d. So little d equals the difference in elevation from the PVI and the mid-chord divided by 2. Okay? So it's the difference in that PVI. It's the difference between the point of vertical intersection and this. Okay? So divided by 2. So 469.67 is the PVI elevation. Okay? And minus this, because we're getting the difference between them, which is 3.75 feet, 2. Now, had this been a hill instead of a dip, this number would have been first because they'd have been opposite. So whichever number is, just follow your instructions when you do this, whether it's a hill or a curve. Whichever number obviously is the largest, either the PVI or the mid-chord, put it up front, subtract the smallest one from it, and you'll get this. Divided by 2, okay? 1.875. Carry this out to 3 decimal points. It just helps the math. It makes the problems come out a little bit clearer, especially for illustration, and sometimes these curves aren't that steep. So 3. That, again, I wrote is a little d. All right. Now, we did that, and we can go ahead and put, well, that's already in there, okay? Now, we've got that. Now we're going to do the tangent offset. Tangent offset, you have to do this problem. This right here is for this one, okay? For this 20 feet. Now, notice earlier I put an X right here. This is what this X is right here for the tangent offset. X divided by 1/2 L, which is 300. 300 is L, so X squared times little d. So in this case, 20 over 150 squared times d is going to be 0.03, okay? And you put that right here, okay? And what we've just figured out was this tangent offset for that 20-foot piece of, that 20 feet right there. That's letting me know it's 0.03 from here to here, Then you just got to continue doing the rest of them. I've done one more. I don't think I have the answer. Then I changed this x is going to be 120. Okay, so we got to do this one. This one's already done. We got to do this one, and this one. Keep changing x, 20, 120. Do it again at 108. Do it again, x as 80. And you'll come up with these numbers right here. Those numbers are on this red line right here. That's what these are. 3, 1.2, 1.87, 0.93. Then simply you add, this is going up, to this tangent elevation to get the curve elevation, okay? This elevation plus 0.3, this elevation plus this elevation plus that, this plus that, this plus that. And that's what we've done. These will be zeros because this is where the road meets the curve, where it levels out, where it started, where it ends. So that's 0. Those numbers stayed the same. I don't even think I put that down there. Yeah, this is 4. I didn't write that one. That should be 468.62 right there. I didn't put the last one. But these are the ones that's more important. What we're worried about is 0.03 plus this is this. This plus this is this. Okay, so far so on. Add them up and you get the elevations all the way across. Then you need to check your low point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Need to do a better chance getting this lined up. That's easier said than done. Okay, 467.65. That should be the low point when you do your work. That needs to be the lowest number in the problem. Ladies and gentlemen, that's how you do the vertical curve. Looks easy to me.